This is Mr. Weideman, and I'm here to help you with this test review problem. This problem also showed up in our homework with the helicopter dropping, I think it was a camera. Also, some of the UT assignments had very similar problems. It all starts if we release an object from something that's moving up or down. Here it's a hot air balloon. Okay, the hot air balloon is moving up, and this release happens at 100 meters of altitude. Now, once the object, in this case a ballast bag, is let go, we need to think about what the motion is going to do. Well, it starts going upward because that's what it was doing when it was attached to the hot air balloon. As soon as it becomes detached, it's now in free fall, which means that its velocity is going to slow down by 9.81 meters per second every second that it tends to rise. So very quickly, this velocity is going to come to a stop. And then after it comes to a stop, its velocity is going to start increasing, but in the negative direction. Velocity will increase by 9.81 meters per second every second that it drops. Now, as long as we keep straight, our initial point here is at release, and our final point is either here at the apex of the altitude or here at impact. And so long as we are consistent, then the problem is going to come out okay. The first thing that they ask for is, well, how high is this thing going to go up? Well, usually when we're solving kinematics problems, one of the most valuable things that we can solve for is time. And we can do that here. It's still a good strategy. And we can use this equation. Here, I'm going to call my final velocity this 0 right up here at the apex. The initial is the velocity that the bag was going at the time I dropped it. It was going 2 meters per second upward. Its acceleration is downward. This makes sense because the bag is going to slow down to a stop. And I'm going to find that time that it's going to move upward until it goes to a stop. Now, once I've got that, then I've got this time, and I can plug it into a distance formula. And if I just want to find this upward motion, then the variables I'm going to put in here is how far it went up. Started out moving upward at 2 meters per second for this time that we previously computed here. That's not a subscript. It's a superscript. There we go. And that can find this distance, which I need to add to the 100. And it's going to be here, and then it's going to fall all the way down. Now, if I want to find this velocity at impact, again, I could use this equation. Here, my V final is unknown. This is not going to help me. And I need to stop, put this in Movie Maker, and cut this out. Okay, an alternate way of solving this problem is I could use this. Now, if I am just concerned about my upwards distance, again, my velocity at the apex is going to be 0. V initial given. This will accomplish the same thing without the intermediate step of finding time. Now, for the next part of the problem, things get a little bit more difficult. I need to find this final velocity at impact. And there's a couple ways about going about this. Some are going to be easier than others. All right, again, one of the most effective strategies is to find time. Now, how am I going to find time? Well, we can use this. Now here I need to be careful. Watch what I do with my distance or my displacement. Negative 100. Now why do I call it negative 100? Because remember, I have to be consistent with the point I call initial and the point I call final. Initially, it was released here, and at the final point, it is down here. So it is negative 100 meters below my initial point. The initial, it was moving upwards when it was released. It's in free fall. Okay, now what I have here is I have a quadratic to solve. My favorite way to solve quadratics is to put it in my calculator and see where it crosses the x-axis. Make sure you rearrange your terms accordingly. You can use the quadratic equation if you like, but there's a lot of susceptibility for computational error. Now, there is another way to do this without solving this quadratic. Let's take a look at this. If I want to get this final velocity, all right, now I'm going from this point to this point. So what is the vertical distance between those two? Is negative 100. My final velocity here at impact is unknown. My initial velocity at this point is at 2 meters per second moving upward. Signs here are very important. It is in free fall, so I can use 9.81, and I can solve for V final. Now, once I have V final, I can go back to here if I wish. And I can compute the entire amount of time that this bag was in the air. That includes all this time to go up and then fall all the way back down. Right here, I'm going to use the V final that I computed here. V initial is given. And I can solve then for this time will be the total amount of time that the bag is in the air. And this saves us a lot of intermediary work. We don't have to find time. All right, so complicated problem, many different ways to solve it, some easier than others. As long as you understand the physics and how to properly use your equations, several different methods will yield your right answer. Good luck with this problem and work well.